And what we see here is that the TMS measurements are closer to the other satellites than they are to the reanalysis, which tells us that we're observing a state of the atmosphere that has information that the reanalysis doesn't have. So we should be able to improve forecasts. Finally, we also use radio occultation profiles, which are very good at measuring temperatures in the upper troposphere and stratosphere. And we also find there that we see similar or better performance of TMS compared to those instruments when we compare it to ERA5. So on the whole, we're seeing that the data quality is good. In many cases, it approaches the noise level, and even in channels where the scenes are very complex and have a lot of clouds and water vapor features that aren't well represented in the models, we still measure other satellite or compare to other satellites better than we do the reanalysis. We also look for things like biases with respect to latitude. Those tend to be very small, as you can see in this image from some of our newly launched satellite, TMS-10. And also across the dynamic range from cold scenes to warm scenes, we don't see any trends there. We mostly line up right along that one-to-one line when we compare to ATMS and the channels that we have in common. There's a lot more detail on this in this publication that's now currently in a revision and review stage, but a preprint's available online at this link. We've also had some independent validation. This particular comparison comes from Professor Mitch Goldberg at CCNY. And he took an approach where he took our data and matched it up to the ERA5 reanalysis and then attempted to retrieve the state of the atmosphere on an independent time period just based on the information that was present in the TMS channels, noise and all.